So I probably have the hardest slots in the entire conference here because it's right after lunch and all of you have full bellies and get the sleepies, and so I'm going to have to do a song and dance or something up here, I guess. Anyways, before I begin, I also want to thank all of the sponsors, the gold, silver, and bronze sponsors, for actually making this event happen. It brought me here to this lovely city, which I've been wanting to come to for decades, and this is my first time in Barcelona, so I absolutely love it. So anyways, what's that? I know, Victor. Anyways, it was, and also just for making this event happen, for bringing us all together so that we can actually exchange ideas and talk about software architecture. So, so thank you, all the sponsors. It's fantastic. I want to talk actually about architectural thinking and what architectural thinking is. I suppose we can define it as thinking about the architecture, but what does that really mean? I want to show in this talk 3 factors to be able to think like an architect. You may have the title of architect. Maybe you're playing the role of an architect. Maybe you desire to become an architect since you're here. Any of those 3, you may have those qualities, but are you thinking like an architect? And that's what I want to talk about in this talk. Let's see the 3 factors, and then I want to dive into these fairly deeply to actually see how to accomplish each of these factors and think like an architect. Thinking like an architect, first of all, is actually being able to understand, analyze, and also recognize all the trade-offs associated with a particular solution or option available. Thinking like an architect is also being able to understand the business drivers associated with the problem you're trying to solve, and also being able to translate those business drivers into architectural characteristics, those quality attributes. And finally, the third, thinking like an architect, is being able to have that breadth of knowledge, that wide scope of knowledge, while maintaining some level of technical depth. This is necessary in order to think like an architect. Let's actually take a look at the first aspect and kind of analyze this in depth. And this is about architecture trade-offs. So I'm going to show 4 different kinds of trade-offs that we might face as architects, real scenarios. I kind of want to start, though, with something non-technical, something that we see every day, such as this airliner right here. Did you ever wonder, as you're kind of looking at planes or flying in a plane, you notice that sometimes the engines are mounted under the wing, and sometimes they're mounted on the tail? Which is better? What's the difference? Architectural thinking, and we're going to get into some technology decisions, but architectural thinking is being able to analyze the trade-offs of each choice to make the right decision. Let's actually analyze wing-mounted aircraft, because if we take a look at the trade-offs associated with this and some of the benefits, or I like the term we used actually in our panel, challenges and opportunities. I think that's what George had used as a phrase. Somehow it came up. It was either David or George that said challenges and opportunities. I like that. Some of the opportunities here. First of all, those engines, when they're mounted under the wing, are closer to the ground, so they're easier to maintain. If we have to quickly change the oil, I don't have to get all these lifts and ladders. The engine's right there at eye level for me. That's a huge advantage. The other one here, I can actually have larger engines. And as a matter of fact, if we go back to this one, lower to the ground, think of those engines way up at the tail. It's a lot harder to maintain. Another factor is I can have larger engines here. Because of the structural elements of the back of the tail, I can only have a certain size engine before the structurally starts falling apart. But under the wing, I can have large engines there. It's a lot of structural support. As a matter of fact, I can have a lot of engines under that wing. If I mount them on the tail, I'm usually, not always, but usually restricted to 2 engines, or in some cases, 4 small engines all stuck together. Here, I can have 4 engines, 6 engines, 8 engines, as many engines as I want to. The other advantage here is that it helps control something called wing flutter. Any sort of structure has vibrations in it, and this is called wing flutter. It happens in aircraft. Actually, it happened to a famous bridge where, near where Ian lives, the Tappan Zee Bridge on the Tacoma Narrows. Flutter caused it to just continue to flutter, and it started falling apart. This happens in aircraft as well, but if those engines are mounted under the wing, the nice thing is it controls all that flutter. This is a huge advantage. You know, the other factor is, well, this is kind of a bad factor, isn't it? Assuming there's an engine fire, which we don't want it to have, how would you think if, like, your window is right there on a tail-mounted engine and that engine catches on fire? It's right next to you. Whereas here with the wing-mounted, those engines are further from the fuselage, a lot safer. Well, that kind of seems like a lot better advantage, doesn't it? But let's analyze the trade-offs associated with that. Because if we look at tail-mounted aircraft, we start to see a whole different kind of world appear. First of all, it's a lot quieter. You know, engines are loud. And as a matter of fact, those wing-mounted planes that we fly in, no wonder the cabin is so loud. Because the exhaust, well, for first class and business, it's not. It's like, I don't know what you're talking about. It's very quiet. For those of us in economy and coach, however, it's fairly noisy because we're right behind the exhaust of those engines. However, tail-mounted, that exhaust is way beyond all the cabin, hence the noise. So they end up being a lot quieter, for example. Here, you know, those engines close to the ground, sure, that's easy maintenance. But boy, you ramp up those engines and it sucks in all sorts of gravel and debris and dirt, and that can actually destroy or damage the engine. Here, they're way up high. So that's not so much debris being sucked in through those engines. Starts to seem like a lot better. You know, yeah, we have wing flutter here, but a lot more efficient, everybody. So the point is now, there's nothing blocking that airflow through that wing. So this is a lot more cost effective. What do you think? Which one do you like better now? This is thinking like an architect. Now we're going to see real solutions that are real problems that we have. But I just thought it might be fun to kind of do just something we see every day like aircraft. And the answer, of course, it depends. Depends on what's more important. It depends on our use case for each of these because it's all about the trade-offs. All right, let's think like an architect on some real problems that you probably are or will face in your travels. Here's a situation where we've got a producer. Let's say we have an online auction. Let's do an online auction where I can bid on items just from home, online. So I've got a producer, that's us, that's sending all these bids. Do I hear 200? Yeah, there's 200. 210? Yes, there's 210. All these bids are coming through. But we have 3 different consumers of these bids. We need to capture the bids to determine who won that particular ask price. I want to be able to track the bids, find out who's bidding and who's not. I also want to do some bid analytics. What's our average bid price? What's the max we've ever gotten? Here's the question. Should I use point-to-point messaging with queues so that each one of those consumers has a queue in front of it, or should I choose to use publish and subscribe messaging using a topic? This is architectural. It impacts the structure. It also probably impacts ilities. Which one do you like better? It depends. Yes. You know, here's the funny thing, everybody. Every single solitary answer that you give as an architect only contains 2 words. It depends. And that gets rather annoying. So let's actually expand it to say, yeah, I know it depends. It depends on what? Let's actually do a trade-off analysis. This is thinking like an architect. All right, point-to-point or publish and subscribe. Let's take a look at publish and subscribe first. You know, I would choose this option hands down over the other one. Why? Quite simply, this is how you implement architecture extensibility. When we talk about that ility or that characteristic called extensibility, what does that even mean? What it means is the fact that I don't have to change anything in my system or structure or architecture to be able to add another kind of service. For example, maybe I want to do bid history. I'm going to start tracking bid history. You can see all the bids you've ever made in the world. I want to add that component or that service. Point is here, go ahead and add it. As a matter of fact, the data is there. It's in the topic. You can go ahead and grab it. Nothing changes. As a matter of fact, this gives us also a level of decoupling. The point is that producer right here doesn't know about any of these consumers. I'm simply sending out bids. I don't know what's done with them. That's a further level of decoupling. So I get not only a more loosely coupled system, I also get extensibility in the architecture. If you want to use the data, then just go ahead and use it. Clearly, that's the best approach. Or is it? Architectural thinking is being able to see, recognize, understand those trade-offs, and then be able to analyze the trade-offs. And here's a key point. If you don't see a trade-off, it simply means you haven't found it yet. It exists. So part of architectural thinking, aside from a developer, thinking like an architect, is actually analyzing those trade-offs. Let's actually analyze those because, well, that sounds really nice. Okay, you sold me. We've got to do that. But wait, because there are some implications. Oh, let's talk first about point-to-point. Because, well, here, notice the producer needs to know everything here. No, I don't have extensibility. If I wanted to add, what would I need to do to add bid history? Store the history of all my bids. I'd have to add a new queue in that broker. I'd have to modify the producer to be able to connect to that queue to send yet another message out. That's 4 messages I would be sending out. This is going to take a lot of time. Clearly, this is not a good option. Or is it? Let me ask you the first question. Who has access to those bids? You see, in a point-to-point model, I don't know. As a matter of fact, anybody has access to that data if they want it. Here, if I send those to specific queues, I can control the access to that data because those consumers tied to those queues are the only ones who can actually receive that information. Oh, if somebody wiretaps in to start getting some of that data, I'm going to know about it because I'm going to have drop messages everywhere. So I've got data security. It's another interesting one. How many contracts can I have here? N. N being the number of consumers. In other words, I can support heterogeneous contracts here. Because Dave right here does not want all 15 pieces of information about that bid, the item, what the auction is, how long the auction's been going. I have all that information, everybody, what the prior bid was. All David wants is what is the current bid? But yet, now I can give him that data. You see, with point-to-point, with publish and subscribe, if I were doing a topic, that's a single contract. You get all that data. But remembering fallacy number 3 of distributed computing, bandwidth is infinite. So of course we don't have to worry about that. Yes, we do. And then so the point is here I have heterogeneous contracts. I can optimize with that and give more consumer-driven contract support. Also, I can monitor those queues. I can monitor those to say, seems like David's getting a lot more messages than everybody else, or he's not processing them fast enough. I think we need more of David around. And so the point is I can programmatically auto-scale and based on analyzing that queue depth through a channel monitoring pattern. I cannot do that with the publish and subscribe model. I can't see the queue depth in a topic. And so I don't have that auto-scaling capability anymore. So much for reactive architecture. Yeah. So now which one do you like better? Again, it becomes all about the trade-offs. And as we know, it depends. Which is more important? Extensibility in our architecture or the security of data and the heterogeneous contracts that I want? These, everybody, are the conversations that we have with the business stakeholders, extracting, understanding, and analyzing these trade-offs in a collaboration with stakeholders. This is thinking architecturally instead of just kind of new shiny things appearing and we say, ooh, that's really good. I love this example. Google Remote Procedure Call, gRPC. gRPC, as a matter of fact, Len talked about protobuf. As a matter of fact, Google's Remote Procedure Call sits on top of protobuf with HTTP2 for a persistent connection. It guarantees at least a 10 times performance increase in latency over REST. Meaning, if your round trip RESTful call, synchronous, is 100 milliseconds, pretty typical. If I use gRPC, what would you say if I told you I can reduce that down to about 8 milliseconds? Sign me up. Architectural thinking says this. Okay, I think that's good. But what's the trade-off? And I'll tell you what that trade-off is. It's tight coupling between services because it's a remote procedure call. I have a piece of your code. I have a client stub there. And so the point is, it's about really understanding and looking at those trade-offs. You know, you wonder why architects are always grumpy. They always have a frown. They're always cynical. They never get happy about anything. Why? They never get excited. They're always moping around. Why? Because everything's a trade-off. You can't get excited about anything until you actually understand every aspect of a system or every aspect of a solution. Oh, let's look at two others that are very common and that I end up seeing in most of my tour as a consultant. And that is this: service granularity. Ooh, let's talk about that. A really hard decision to make. Should we make our services coarse-grained? In other words, macro services that contain most of the domain. Or should we make them fine-grained, super small, single-purpose, single-responsible services that do one single thing really well? What do you think? It's all about trade-offs. It's thinking architecturally. Let's actually analyze what the advantages and disadvantages would be from each of those. Because with coarse-grained services, we may get all excited about granularity. But with a coarse-grained service, look what we get. I have a database transaction now. Because, as George mentioned, start transaction, gasp. Do activity A, activity B, whoops, error, rollback. Yeah, in a coarse-grained service, I'm not communicating with other services as frequently. I can actually get an ACID or a database transaction. As a matter of fact, as a result of that, I get better data consistency. Albeit, it's still a distributed transaction, but better data consistency. And because now I can actually have that transaction to do the payment at the same time that I place that order. That may be a business requirement. I cannot give you an order ID for one of Len's books until your payment has been applied. That's hard to do in distributed architecture. It's called a saga, or base transaction. Here, that's an ACID transaction. I just roll back. The order never happened. You got to pay for it. There's no state machine here. And as a matter of fact, as a result, I get a lot better performance as well. You know, performance, and because I'm not calling any other service. As a matter of fact, those calls are method calls or function calls, which are microseconds or sometimes even nanoseconds. Finally, another big benefit of this is reliability. And I'm not leveraging the network. Oh, but that's fallacy number one of distributed computing. The network is reliable. No, it's not. You know, we think it is, but it's not. Oh, it's much better than 1973 when Peter Deutsch and a lot of other folks from Sun Microsystems coined those 8 fallacies of distributed computing. But it's not reliable. But with coarse-grained services, I'm not leveraging the network as much. And so within that domain, we've got a lot better reliability. Wow, you're right, Mark. I don't think we would ever want to do fine-grained services. But wait, there are advantages to those. And here's the trade-off, everybody. First, high levels of agility. That ability to respond quickly to change. If I have a small, fine-grained, single-purpose service with a particular function, it's a lot easier and faster to change that as opposed to a larger domain. In other words, scalability. I've got function-level scalability here, as opposed to scaling out the entire domain. Ooh, we do need that. Also, better levels of testability. Testability being that not only ease of testing, but the completeness of testing. If you make a change in a coarse-grained service up there, are you guaranteeing me that you've tested every scenario through that coarse-grained service and that there's no bugs introduced? Of course not. However, with a small, fine-grained, single-purpose service, yes, I can guarantee that because it's fairly straightforward to write a full regression test against that small service. And finally, deployability. Deployability, that low-risk, frequent deployments. Boy, they both sound good. If you're going to go get some gelato, should it be vanilla or chocolate? I don't know. I like them both. Architects can't make any decisions because we're constantly analyzing the trade-offs of vanilla versus chocolate. Yes, neither will do strawberry. And the point is this: which one should we choose? This is thinking like an architect. It's analyzing those trade-offs to say, well, it depends. Of course it depends. Which one's more important? This, everybody, thinking like an architect, is what facilitates those discussions with key stakeholders, those business stakeholders, We as architects cannot make those decisions. What we can do as architects is be able to know what those trade-offs are so we can articulate those to our stakeholders and have those conversations. Let's look at one more. I'm not going to ask for a show of hands because I know how many hands would be raised. All of them. Because we all try to think that loose coupling and strong cohesion are two core principles in architecture. We want to strive for loose coupling and strong cohesion. Coupling being the degree and manner to which other components or services know about each other, and cohesion, which is the degree and manner to which the operations within a particular service or component interrelate. Let's talk about loose coupling. I bet every one of you, or at least 90% of you, would be in favor of loose coupling. Let's actually analyze loose coupling to see whether there's a trade-off or not. So I'm going to show you an actual system right here. These are all services. Call them microservices if you want, or just regular services, it doesn't matter. I've got an order placement service. This service does one thing really well. It knows how to validate and place an order. I've also got a notification service. This separate service right here does one thing really well. It notifies all of our customers. Your order's been placed. Congratulations, it's been shipped. It's been fulfilled. It's on its way, so on and so forth. I've also got a payment service. And this payment service is responsible for applying the payment to that order, and whatever it might be, a credit card, store credit, gift card, whichever. I've also got an inventory service right here. That inventory service has all the inventory of all of our products. We know how many of Len Bass's books are left. That service knows it. Okay. We also have a warehouse service. And the service right here knows where Len's books are and which warehouse. Do I need to kind of load balance that inventory to be able to guarantee a 2-day delivery on Len's book? I'm assuming I can get it in 2 days, right, Len? Yeah, okay, good. And finally, the supplier. In other words, all of us have been purchasing Len's book in our examples, and so we've run out. And so we need more in stock. And that's what the supplier service does. It knows for Len's specific book which publisher to go to and contact. Okay, let's place an order, everybody. So I place an order. What happens? And these are going to be synchronous RESTful calls. Well, I have to apply the payment. Come back right there. Comes to the order. What do I do next? Well, I got to decrement that reserved inventory. Okay. We've only got one book left, folks. Now I notify. Congratulations, you've got the book. It's on its way. Here's your order ID. All right. Meanwhile, though, the inventory service says there's only one book left, and it notifies the warehouse service to say, by the way, can you load balance? Can you move something from one warehouse to the other? Nope. Sorry, there's none left anywhere. And so now the inventory service says, okay, I'm going to go to the supplier and order them. We talk about loose coupling and various aspects of coupling. The formal terms are afferent or efferent, afferent being fan in or incoming coupling, efferent being fan out or outgoing. In other words, who am I dependent on? Let's actually analyze the coupling level. CT is going to be the total coupling. Well, look at the placement service right here, or the order placement. That has 3 outgoing. That totals 3. What about notification? 1 incoming. That totals 1. Payment? 1 incoming. How about inventory? That has 1 incoming and 2 outgoing. So that total coupling level there is 3 to other services. As a matter of fact, warehouse is 1, and supplier has 1 afferent or incoming. So that totals 1. You know, this simple system right here has a total coupling level of 10. And in my opinion, I think that's quite high. You want to make it 0? Let me show you how to make this coupling level 0. No coupling whatsoever between services. All right, let's change the topology just a little bit. I'm going to add a topic on top of the notification, payment, and inventory service. I'm going to add a queue for warehousing, and I'm going to add a queue for suppliers. Now, watch this. Let's place an order for one of Len's books. You ready? Order placement gets that, and what does it do? It sends a fire and forget asynchronous message or publishes it to a topic. It's done. Now, here's why it's decoupled. Do you know which services are going to access that? Do you even know it's a service? Is it 10 services, 1 service? Is it a human? I don't know. I'm simply just sending it to a topic. That's it. Now what happens? All 3 of those services subscribe to that topic. They all get the message at the same time. Payments applied, you're notified at the same time. Inventory says, okay, decremented inventory. Whoa, we only have one left. Well, let me just tell the warehouse service, deal with it. And so it sends a fire and forget message to a queue. There's no idea if there's even a service, maybe it's a back-end system, send it to a queue. And then the warehouse service picks it up and goes, there's no, we're out. And so it in turn delegates to send a message to say, got to order more. I don't know who does that. I don't know, but got to order more. Take a look at that, everybody. That coupling level right here across all those services is 0. That is a fully, loosely coupled system. That total coupling is 0. Because not one service is dependent on the other. I'm not waiting for anything to happen. Beautiful. Or is it? Yeah. You know, we all strive for loose coupling. However, what we fail to realize, thinking as an architect or thinking like an architect, is that everything we do and every decision we make carries with it implications and trade-offs. What do you think one of those might be? Looking at this. I mean, that's wonderful stuff. You know, what happens if an error occurs? Yeah. What if I can't apply a payment? How do we know when it's complete? Do we have any control over this workflow? No. How about control over the transaction? How consistent do you think the data is? All these are the issues. You see, when we start analyzing loose coupling, the point of this exercise is to say that a lot of the trade-offs we do, folks, are not binary. It's not a 0 or 1 or A or B, but rather it's a gradient. For example, decoupled services. Clearly, that's fully decoupled. I mean, the coupling level there between services is fully 0. However, yeah, let's talk about workflow control. None. However, I've got full workflow control over on the other side of that tightly coupled system. As a matter of fact, error handling, yeah, if payment doesn't work, it comes back to order placement. And I can immediately, I'm talking to you already. And so I have control over that. I can actually handle those errors because it's synchronous. Furthermore, what about data consistency? Yeah, the tighter the coupling, the better the data consistency. And finally, what about transaction management? And I don't mean a database transaction, but I mean that business transaction of actually buying one of Len's books. When does it stop? When does it end? Did it work? Did it not work? I don't know. I'm responsible for payment. David says, I don't know. I do warehousing. No one knows. Quite simply, no one knows when that's done. Now, we can circumvent some of those by adding complexity, by making a lot of messaging between there so that order placement knows, but there's a lot of complexity. And so the point is this: which one do you want? And like I said, here, it's not about A or B. It's about the level of coupling, understanding those trade-offs. This is something we deal with in any system. So when you hear, you got to do loose coupling, as an architect, you say, well, wait a minute. Let's see how important some of those other factors are. Okay. A couple of things to remember. In architecture, there are no right or wrong answers. It's all about trade-offs. And the corollary to that is as follows. There's never any good trade-off. Ever. It's only the least worst trade-off that you end up having. Yeah. 2 golden rules of architecture. There you go. You can take those away. Okay. Let's talk about another aspect, actually, that Len touched on in his talk this morning, and that's about understanding business drivers. Thinking like an architect is understanding the business drivers and not getting caught up in an anti-pattern called the cart before the horse anti-pattern. You see, this anti-pattern happens when we don't think like an architect, because we make choices based on an opinion or a knee-jerk reaction, or just, I don't know, it looks new, we'll try it out. We don't base our decisions on any grounding. And that's putting the cart before the horse. Let's see an example. Understanding those business drivers, Len had showed quite a few of those in his slides. This is the language of business. User satisfaction, speed to market. How fast can I actually get these changes out or that bug fix? mergers, competitive advantage, regulatory compliance. This is all the language. This is our language, everybody, the ilities. I like to call them architecture characteristics. And here's the point. Putting the cart before the horse is not actually analyzing these ilities or being able to extract those, because we start making decisions about architecture styles, for example. Should we use microservices? Well, yes. Everybody's doing it. Of course we should use it. And the point is, thinking architecturally is actually analyzing those business drivers and the corresponding ilities to those. And here's usually what happens. The architect says, oh, by the way, we're supporting high levels of agility, fault tolerance, and testability in our architecture. And in most cases, you know what the business stakeholder says? What are you talking about? Because this is not their language. As a matter of fact, Len talked about add any word and add the word ility to it. Carlos ability. I wonder what that would be, Carlos. Yeah, well, let's not analyze that. You know, I sometimes do this on teams. We take different personalities on my development teams, and we start to add ilities to them. You know, if you've got somebody who's totally bent on perfection, like they can't even get their code done because it's not right yet. No, I got to spend another week. Well, let's say that person's name is George. That would be George ability. George ability would be the ability to be perfect. It has to be right. You know, so that's kind of fun to do. But here's the point. There's a lost in translation that happens. And because architects are talking one language and the business is talking another. What we need is some sort of collaboration between this, a translation. This is thinking like an architect. For example, time to market. Oh, time to market. Is that time to marketability? No. What that translates to are high levels of agility, that ability to respond quickly to change, combined with testability, ease of and completeness of testing, along with quick and low risk deployments. All three of these lead to time to market. And the point is, here's all of our choices. We can do a layered monolith. That's our traditional n-tiered layered architecture. We can do a microkernel, microservices, service-based, event-driven, or even space-based architecture. And the point is here, which would you choose? Because those are the three important ones. Agility, deployment, testability. You know, if that's what's important to the business, and you have layered, monolithic architectures, I'm not sure you're going to succeed. But rather, these architectures with 5 and 4 stars is the right choice. But you notice, I made that choice not just based on popularity or RDD, resume-driven development, but rather, I made it off of a grounding based on business need. But that business need was not agility. That business need was time to market. Let me do one more here. How about this one? Let's say that the business says user satisfaction. Whoa. Like, above all, I don't care about scalability. I don't care about, I care about you. Our users have to be happy because we are in high competition with other companies. That's what we pride ourselves in. Make it happen. Notice I didn't say anything about what kind of application it was. So the point is this. What is that? User satisfaction ability? No. Thinking like an architect is knowing what things upset you when you're working in your favorite website. Performance. Does it go up and down? Availability. Testability. Are there bugs? All of these factors lead to user satisfaction. As a matter of fact, if that's the most important thing, let's see what architecture styles might look good here. Whoops. Yeah. No wonder our users aren't happy, because we're stuck with this kind of architecture style. And so the point here, microservices, service-based driven, and event-driven architecture architecturally supports those ilities, which makes our users happy. All right. Let's do one really quick. How about budget and time constraints? There was a question about budget and time, of which I'm not doing well on right now. Yeah, what is that? Budgetability? No. If our costs, these are constraints. As a matter of fact, yesterday in our workshop, we talked about every architecture decision potentially is really a constraint that development teams work in. Because here, quite simply, it's simplicity and cost. And as a matter of fact, if we take a look at the architecture styles, and we make the wrong choice, well, what do you think would happen here? Now, 5 stars means the best. It doesn't mean it costs the most. It means it's the best. Let's use microservices. Right. One of the most complex architecture styles I've implemented, and it's really expensive. Yeah, we're going to crash and burn. Yeah, it's clearly here. A monolithic architecture is really what fits. And the point is this, translating these is remembering that performance does not equal user satisfaction. If you say, oh, well, we got to focus on performance, you will fail because it's all those ingredients. It's like asking you to bake me a pie and you giving me a bowl of flour. That's going to be really bad. Yeah. All right. Let's finish up with one other aspect, and that is gaining technical breadth. One of the other aspects of thinking architecturally is maintaining that technical breadth of knowledge. And what do I mean by that? This triangle right here represents all the technical knowledge in the world, and that's what you know right up there. A small little piece. This is stuff you do on a daily basis. You can get up here on the stage and talk about it. This is stuff you know. But there's two other levels of knowledge. Then there's the stuff that you know you don't know. A good example of this might be closure. Okay, I'm sure, I'm hoping, as technologists, we've all heard of closure. But I'm betting only a handful of you can effectively code in closure. It's a good example of something that you've heard of. You know about it. You gotta love parens if you're doing closure. But the point is, you really can't code in it. But then the biggest area of knowledge is the stuff that you don't know that you don't know. How many of you have heard of deep prior images? Deep image priors. There we go. There's something that you don't know that you don't know. And the point of life, really, your career, is to take stuff that you don't know that you don't know. You've never heard of this. Learn about it and move that into the stuff now I know I don't know about. I've heard of it before. Yeah, I know what it is, but don't ask me to be an expert, and don't ask me to come up here. And then based on need or just something that intrigues you, piques your interest, then you move that stuff. Oh, by the way, Len, we're using deep image priors tomorrow. Oh, well, I better learn about it. And then you become an expert. But here's the cautionary tale. Be careful of what you put up there in that top area of knowledge, because that's the stuff you have to maintain. And unless you don't sleep or don't have kids, be really careful about what you put up there, because it will trickle down. Now, here's the point. The stuff you know is called technical depth. Every technologist, even architects, need a level of technical depth. But the stuff that you know, plus the stuff that you don't know, is considered technical breadth. And the key point, this is where to focus when you're thinking as an architect. It's required. I need to know about 12 different caching technologies, not just one really deep. Okay. So what I do is I look at three areas here. InfoQ, infoq.com. I look at dzone ref cards and also ThoughtWorks. Yeah, like we all have time for that. Let me close by saying, here's what I do, everybody. What do you do when you get to work? I call this the 20-minute rule. How would you say? 20 minute. 20 minute? 20 minute. There we go. 20 minute. 20-minute rule. And that is this. 20 minutes a day devote to your career by taking stuff that you don't know and moving it into the stuff that you know. Go to these three references right here. As a matter of fact, let me spend one more minute. I know I'm out of time, so I'm going to spend... Oh, actually, I have 30 seconds left. So here, look at what happens on InfoQ. This is free stuff, everybody. This is all free. Register with the website. Every 3 days, I get an email. And look at there, deep image priors. Click on it. Say, what in the world is that? This is the stuff that you don't know that you don't know. The whole key here is to start looking at buzzwords you've never heard of. Bring those into that middle area, albeit it's probably this area. Bring that into your area of knowledge. I spend 20 minutes a day doing this. Now, here's the tip though. What do you do when you get to work? I'll answer that. You grab that blessed cup of coffee or tea. Okay. What's the very second thing you do? Check email, and your day is over. Yes. Don't save this for lunch. Don't save it for the end of the day. 20 minutes in the morning. Get there a little early. Grab that blessed cup of coffee or tea. Sit down at your desk or table if you're working from home, and spend at least at a minimum 20 minutes to devote to your career as an architect, gaining that technical breadth. Then check email. Doing this allows you to gain that technical breadth of knowledge. Fantastic. Okay. I am out of time. However, I will be outside. I'll be out there during the break if you have any questions. I know I probably didn't allow enough time for that, but anyways, thank you all so much. All right. Thanks. All right.